So today I have a question for us to solve, and this is the question on the screen. So when they give you a question like this to solve, what do? The first thing you're going to do is that you're going to label this place as left hand side, and you're going to label this place as the right hand side. So now I will start with the right hand side. Okay, so the right hand side is already here. I've written the question out here. This is the right hand side. So let me solve this now, okay? For now, I'll take this paper off and later I'll bring it back. So again, this is the right hand side. So let's do it. So watch. So for me to do the right hand side, what I will do is this. I'm going to rewrite this expression. So what is A minus B? This is A intersection B complement. That's the meaning. Then this is union. What is B minus C? This is B intersection C complement. Then union. What is C minus A? That is C intersection A complement. Then union. Then we now have A intersection B intersection C. Then you will notice something that A intersection is here and A intersection is here, so I can bring these two close to each other. These two, I bring them close to each other. Okay, so how will I do that? That will give you A intersection B complement union A intersection B intersection C. Do you understand? Then I will now continue with the other union. So what is the union? We have union. Then we have this B intersection C complement, then union C intersection A, then complement. I think we understand this up to this point. Okay. So from here, what am I supposed to do? Watch. Now you will notice that we have A intersection here and we have A intersection here. So what I will do is that I'm going to use distributive law. So I'll bring out A intersection, then I'm going to open a bracket, and I'm going to write B complement union open bracket B intersection C. Let me tell you what I did, because it might look somehow. See what I did. I removed this first two. I removed the first two. So if I remove A intersection, it will remain B complement. Then union, if I remove A intersection, it will remain B intersection C. Can you see it now? So I removed the first two. Do you understand? So in exam 2, you can remove the first two so you can see what you're writing better. Then we have union, right? Then we have these red ones. So the red ones now, this is B intersection C complement union, and this is C intersection what? A complement. Do you understand? Now, let me show you something. Now, at this junction, I will do one small thing. So what I will do, now this union will come inside. And when it comes inside, I will use a law. The law is called distributive law. So watch me. This will give you A intersection. So watch. Now, let me say it. B complement union B. So what I have now is B complement union what? Union B. Do you understand? Then intersection. Then let me take it again. B complement union C. B complement union C. You can see that. So that one is already solved. That's all. So this side, don't touch them. Leave them the way they are. So for now, you can just do like this to avoid writing them again. Later, you can write them back. Okay? All right, to save time. All right, so at this junction, what am I supposed to write? Now, let me show you something. B complement union B is called true. But you might not understand why it is called true. Okay, let me tell you something. Now, the union between B and not B. The union of B and not B is universal set. That is, B union what is not in B. So B union what is not in B. When you join the two of them, you're going to get universal set. That's what we call true. So in exam, you see true. but true is also another way of saying universal set. So B, not B, union B is universal set, all true. Now, the intersection between this and this, we give it this one. Let me explain. You see this thing here, union, is a big set. Why this one here is a small set? So intersection between a big set and a small set, like of this nature, again, the intersection between a big set and a small set is the small set. That means the answer to this question is A, intersection, open brackets, B, complement, union, C. So we can continue with this one. So remember, I said that to save time, you can just write this and tick. So let's continue from here, all right? So at this junction now, what am I supposed to do? I will open this one. How? Watch me. I'll bring it inside. Distributive law again. So this will give you A, intersection B, complement. Can you say it? Union, A, intersections. Can you say that? Then this one, you can add them now. B, intersection C, complement, which is from the top. Union C, intersection A, complement, because that is coming from the top, okay? So you can add them now. All right. Then you notice something. You notice that these two, they look alike. Yes, because they have C intersections. You can bring them together. So watch me. I'm going to have A, intersection C. Then union C, intersection A, complement. Can you see that? Okay. Then I cannot continue with this one here. That is A, intersection B, complement. Then union B, intersection C, complement. I hope you can see that. Now, guess what? In maths, if you don't want this approach, this thing here, you can turn this one to C, intersection A. It's the same thing. There's nothing wrong with that. It's the same. So now you will notice that, yes, they look alike. So I can remove the first two. The first two. So if I do so, I'm going to have C, intersection, open bracket, A, union, A, complement. Do you see that? If I remove the first two there. Then I will continue with union, A, intersection, B, complement. Then union what? B, intersection what? C, complement. Then let me now show you something. Do you remember the meaning of A, union, A, complement? It is called true or universal set. Now, universal set is big. Don't forget that. This one is big. But this one is small. So what do you think is the intersection between this big set and the small set? It is the small set. So that means this one, the answer is C. Then we now have union, this, which is A, intersection B, complement. Then union B, intersection C, complement. Okay, so from here now, what am I supposed to do? Watch. You will notice now that I can bring these two together. Yes. Let me bring them together. Just watch. So this will give me C, union B, intersection C, complement. Then union A, intersection B, complement. So what did I do? I brought these two together. Okay, very good. So let me use another booklet because this will get a bit rough. Okay, so let's continue from here then. Then I will use a law. Look at the law. That is distributive law. So this one will come inside, okay? So watch me. This will give you C. Let me say it first. C union B. C union B. Can you say it? Okay. Then intersection. C union C, complement. C union C, complement. Can you see that? So that one is already gone. Then we now have union what? A, intersection B, complement. I hope you can see this. Okay. Then let me now ask a question. What C union C, complement? That is true or universal set. Now remember, universal set is a big set. While this one is what? A small set. Do you remember? So the intersection between a big set and a small set is a small set. So this is C union B. Can you see that? Very good. C union B. And this one is what? Union A, intersection B, complement. So at this junction now, I can do one small thing. And what is that one small thing? Watch. I can come here and I can bring this one inside. And the question is, how am I going to bring it inside? Watch. So this one here will come inside. So the law I want to use is called distributive law. So in distributive law, this will give me, let me say it first. C union B, union A. C union B, union A. So that one is gone, okay? Then intersection. So let me say the other one. C union B complement. C union B complement. Now, do you remember the meaning of this? B union B complement? It means universal set or true. Now, what do you now think this is giving me? This is giving me C union universal set. So intersection, or let's say C union true. Let me use the word true because true is better for exam situation. Universal set means true, but write true, okay? C union true. Intersection this. So this one remains the way it is. It won't change. C union B union A. Now what do you think this is? This is C and this is what? Universal set. Now this universal set, which is true, is big set, while C is what? Small set. So the union between a big set and a small set is the big set. So this one is just true. Okay. Remember, true is what people call universal set. Okay. So I have true. So this is true. Intersection this. And what is this? C union B and union A. Now what is intersection between true and this? Remember, true means universal set. So what's the intersection between universal set and this? Remember, universal set is a big set. This is a big set. Well, this one is what? A small. So the intersection between a big set and a small set is a small set. That means the final answer here is C union B union A. And guess what? I can write this again as A union B union C. So I'm done with this. So remember, this is the right hand side, right? Good. Now that I'm done with the right hand side, can you now check the question? Can you imagine? I did just the right hand side, only the right hand side, and see how I started. Let me show you how I started. So I started from here. The right hand side. I start from your right hand side, see it here. I solve this up to this point. Then I continue this way. I continue this way, down to this point. So from here, I continued here. I continued up to this point. And now I am here, and this is the answer. Now guess what the original question said? The original question said that we should show that this is equal to that. You can see that the right hand side is A union B union C, and that is exactly left hand side. That means we have proved this, and that's all.